All right, let's talk about solving systems of linear equations. We're going to go from that kind of messy way we all learned back in the day to a super powerful systematic method, one that can handle, well, pretty much anything you throw at it. Think of it as a journey from chaos to a clean, reliable system. Let's dive in.
So, here's what we're going to cover. We'll start with the old ad hoc way, then move to our goal, echelon form. We'll find the key columns called pivots, and then simplify everything down to the ultimate RREF form. We'll look at the deeper meaning of all this, and then wrap up with a quick revision of the core concepts. All right, Section 1, From Chaos to System. Let's start by looking back at that old ad hoc way of doing things. Okay, so this probably looks super familiar, right? Just a simple system. Two equations, two unknowns, x and y. You look at that and you think, yeah, I can handle this, no problem. And you remember the drill, right? We, multiply one of the equations to make the numbers match up, then we subtract one from the other to get rid of a variable. From there, you solve for what's left, say y, and then you plug that value back in to find x. It totally works, but man, it's a bit of a juggle, isn't it? Even with just two equations, you're keeping a lot of plates spinning. So yeah, that's fine for two equations, but what happens when you have 1,000? Or even just 10? Can you imagine trying to do that same juggling act? It would be an absolute nightmare. You'd lose track of everything. There has to be a better, more systematic way to do this. There just has to be. Okay, Section 2, the echelon form goal. This is our systematic target. And you know what? There is a better way. It's an algorithm called Gaussian elimination, and its whole job is to take that messy system of equations and turn it into something clean and organized.
And that clean, organized structure we're aiming for? It's called echelon form. The easiest way to think about it is, well, it looks like a staircase. That's the key visual. We want every leading non-zero number in a row to be to the right of the leading number in the row above it. It creates this nice, neat step-down pattern. Just look at this comparison. It makes it super clear. The matrix on the left, total mess. The leading numbers are all over the place. That is not echelon form. But look at the one on the right. See that perfect staircase pattern? Step, step, step. That is exactly what we're trying to achieve. Section 3, pivots, the key columns. So, now that we know what shape we're aiming for, let's zoom in and identify the most important players on the field. We call these pivots. So, what exactly is a pivot? It's actually really simple. As you walk down that staircase we made, the pivot is just the very first non-zero number in each row, the start of each step. And the entire column that holds that pivot, we call that a pivot column. You can think of these columns as the main support beams of the whole structure. Okay, so if the columns with pivots are pivot columns, what about the ones that don't have a pivot? Well, we call those free columns. They correspond to what we call free variables. But here's a little spoiler. We're going to find out that they're not quite as free as they sound.
All right, let's do a quick practice run. For an exam like GATE, being able to spot these pivot and free columns in a heartbeat is absolutely crucial. So take a look at this augmented matrix. It's already in that nice echelon form for us.
Okay, where are the pivot columns? It's easy, right? You just follow that staircase pattern down. The first number in the first row, boom, that's a pivot. So column 1 is a pivot column. Go to the second row. Find the first non-zero number. Boom, that's the next pivot. The columns with those leading entries are our pivot columns.
So the ones left over are the free columns. Pretty straightforward. But wait, there's one really important exception. See that last column, the one after the vertical line? In an augmented matrix, that column is special. It's not a pivot column, and it's not a free column. It's the answer column, so it's in a category all its own. Don't forget that. Moving on to Section 4, the ultimate RREF form. So, echelon form is great, it gets us organized. But what if I told you we could take it one step further? We can simplify it into a state that is so clean, it practically tells you the answer. This ultimate state is called row-reduced echelon form, or RREF for short. To get here, we just have to follow two more rules. Rule 1, every single pivot has to be the number 1. And rule 2, that pivot, that number 1, has to be the only non-zero thing in its entire column. Everything else above and below it has to be a 0. So check out the difference here. On the left, we've got a perfectly good echelon form. It's got the staircase, but the pivots are kind of random numbers and there's other stuff in their columns. But now look to the right. That's the RREF version. See how clean that is? Every pivot is a 1 and they're the only things in their columns. It's not just about making it look pretty. This super clean form is about to reveal a deep secret about the system. And as Sachin Mittal from Go Classes puts it, what you end up with here are very convenient vectors. And that's exactly the right way to think about it. They're convenient because they're so simple, and that simplicity is what's going to unlock the whole meaning behind the system.
All right, section 5, the deeper meaning. This is where it all comes together. So what's the big deal? Why do we care so much about pivots and free columns and going all the way to RF/REF? What's the payoff?
Okay, here it is. This is the most important idea of this whole explainer. A free column is always a linear combination of the pivot columns. Always. No exceptions. That means you can literally build a free column by taking certain amounts of the pivot columns and adding them together.
And that is the magic of RRFE. It makes this relationship totally obvious. Once you've reduced the matrix all the way, you can just look at a free column. The numbers in that column, they're literally the recipe. They are the exact amounts of each pivot column you need to mix together to create that free column. The RRFE form just hands you the answer on a silver platter.
Okay, final section, core concepts. Let's do a quick-fire revision of the key takeaways, especially for anyone prepping for the GATE exam.
So let's lock these in. Echelon form, that's our target staircase structure. Pivot column, that's a column with a leading non-zero entry, one of our basic variables. Free column, a column without a pivot, which we now know is dependent on the pivot columns. An augmented matrix is just our coefficient matrix with the solution vector tacked on the end. And finally, RREF, row-reduced echelon form. That's our ultimate, super simplified form where pivots are all ones and they're alone in their columns. Really understanding these terms is going to be a game changer for solving problems quickly and correctly.
And that brings up a really big question, doesn't it? We now have this incredible, systematic way to transform any matrix into a clean, simple form. But so what? How does the final location of the pivots actually tell us if a system has one unique solution, no solution at all, or maybe even an infinite number of solutions? That's the real power, and that's exactly where we're headed next.